All right. Now, this is the another chapter, vibration, right? So, in vibration, basically, it's a one subject like in mechanical engineering and all. But in our gate syllabus, it's a chapter. Okay. So, if you go, then it is, as I told, it is one subject. Mechanical vibration, it is one subject. So for that reason, I'm telling it is not necessary to go through all the topics one by one. It is not necessary. As per GATE, whatever the topics they are touching, they are asking question from which topic. That topic I will discuss you. And as I mentioned already in earlier classes also, like derivation, all derivation not important. No? Whatever the important thing that I will tell you, and whatever the derivation suppose is important, like to understand the things, that also I will do. But full derivation like from start to end, not necessary to do. That final result you should know, and that application of that final result you should know, assumptions for that result you should know, how to apply that final result, that you should know. That is important. All right. So now, okay, we'll go for it first. So, like, kind, if you check the types of the vibration and what is the mean of vibration, that very simple. So, vibration is basically, suppose a system which is already in equilibrium position. Okay, one system which is in equilibrium. Simple, I will give example so you will understand. Domestic example. Okay, this is the pan, you can say. Hmm, that's pan here. Just basic example, you just try to understand, you will automatically understand the thing. Okay, this is the pan. Hmm? All right. This is the stove. Hmm? And here you are making tea and all. Okay. If this is the empty span, okay, and if it is empty span, you just hit by a spoon or any kitchen item, you just hit on this span, and once you hit this span, so you may get that sound. Okay, why that sound? And you may get that sound, that is okay, one thing. Second thing, if you hold this span tightly, then that sound you may not get. If you hit this span by a spoon, okay, and leave it, then you may get that sound. Hmm? But if you hit by the spoon to this span and hold it tightly, then you may not get that sound. That reason is very simple, it's vibration. All right, it's a vibration only. Okay, it's a vibration only. Now, so what do you mean by vibration? So vibration is just like a motion. Okay, because naked eyes cannot see that why this sound we are getting by this span. So the simple reason is the vibration. Because of the vibration only you are getting sound. Simple. So how that vibration, you just simple, another example I will give. This is suppose one cantilever strip. Okay, you give the load, to at the free end of this uh, cantilever, and you immediately remove the load. Okay, so this strip will move in this way, to and fro motion. To and fro means like this, and finally it will get initial. So again there also you may get sound. Why? Because of this vibration. So it's kind of the motion. Okay, that vibration is nothing but it's a motion, to and fro motion. To and what do you mean by to and fro? This is the suppose origin point. So this side motion and this side motion, this side motion, this motion to and fro. I mean, this is the center point. this side motion, at the same time this side motion. So this to and fro motion called as a vibration. Okay. So a body is said to be vibrate if it has to and fro motion. And because of that, obviously frequency you may get, right? And that will convert into sound. Okay. That energy will be converted into sound, and obviously sound is one kind of energy. So that you may get the sound. Very simple. Okay. So this vibration basically, we have a three types: huh? Free, damped, and forced vibration. Free, damped, and forced vibration. Okay. What do you mean by free vibration, or called natural vibration also, or free vibration or natural vibration? So, so what is the mean of it? It's very simple. As I mentioned, check. As I mentioned, suppose uh, this is the cantilever. Okay. On this cantilever, if you apply the load and immediately remove the load, so it will start vibrating. It will start to and fro motion like this. Initially you had applied load and you remove the load. Okay. So once you remove the load, but still it is vibrating, then it is called free vibration or natural vibration. Whatever the frequency you may get, it will be natural frequency. You understood what is the free vibration? Very simple. There is no continuous force acting on the system. You may apply load on the system and immediately you remove the load, but still that body is what vibrating, or still that motion is what there, to and fro motion is there. Then it is called as a free vibration. What is the mean of damped vibration? Damped vibration means, okay, like suppose this cantilever is what start vibrating, to and fro motion started, but here you have used the spring system and you fixed this. So this spring will try to get initial condition as soon as possible, because once is this strip will go downside. Okay. Because that motion will be up and down, no? Up and down. So once it will come downside, so this spring will try to oppose that motion. So immediately it will come to its own initial position. Yes or no? Or you can say this side also spring we have. No? So so immediately this strip, if you apply load, it will go like up and down, but automatically it will come to original position. Why? Because both side spring will be there, and this spring will try to oppose that motion. So this type of vibration called as a damped. Damped vibration means damp in the sense to eliminate, uh, to eliminate or to dissipate. That meaning is same. So the kind of vibration where vibration is what going to dissipate, or vibration is what going to eliminate. Okay, gradually means slowly. That type of vibration called as a damped vibration. You may say like damper. We are using damper. So damper is what basically used to damp out the vibration. And what is the mean of damped out? Damp vibration means very simple. To try to dissipate, uh, to try to eliminate the vibration. Okay, slowly. That that type of vibration called damped vibration. What do you mean by forced vibration? Forced vibration means like simple. This is the what cantilever, and in this cantilever continuous force you are applying. So if you apply the force, because this is the strip, this is the why I'm giving the cantilever example, because many times many places you might be have seen in your college time, like in lab and all, or generic also sometimes you have seen this type of the vibration. Like maybe suppose this is the wall, and over this wall, suppose this is iron rod is there. Okay, long iron rod is there here. This is the long iron rod. Sometimes you may apply the load here, or upward or downward, and leave it. So automatically this rod may go up and down motion like this. So this is the practical examples I'm telling you. Okay. Now, but this force is whatever the force you are applying at the frame, it is continuous. Okay, if you apply the load, so it is continuous. Hmm? So this type of the vibration, okay, called as a force vibration. The force you are acting, you are applying continuously. That continuous force is what acting. Okay. Now, simple example I will. Suppose this is the water bucket. Inside this bucket we have water. All right. Now, here some iron rod, or suppose your hand is there and you just rotate your hand inside the bucket. So what will happen? What will happen? Simple, water will try to rotate. Uh, so that shape you may get like this. That water will try to rotate here. Yes or no? So that shape you may get like this. Once water will start rotating, that shape will be like this. You remove the hand, then still that water will be rotating inside. Uh, So still water is rotating. So that is called free vortex. So similarly, if you apply load and automatically remove the load, and if vibration is continuous, called the free vibration. But one thing, if you are here inserting your hand here and continuously rotating your hand inside the bucket, so whatever the water, that water will also rotate continuously. So here by your hand, you are continuously applying load, torque you are applying, hence water is rotating. So continuous rotation of your hand give the rotation to the water, and water is also rotating. That type continuous you are imparting the rotation to the water. So continuous rotation of your hand is the symbol of force vortex, and in terms of vibration it will be force vibration, right? And if you dip your hand and rotate it and remove it, but still water is rotating, it is called free vortex, and in terms of vibration it will be free vibration. I hope all three difference you might be understood. You tell me, you understood or not, all three?
Yes, sir.
It is clear?
Yes, sir.
Okay. So, uh, by this example, okay, this is the one example here it is given. So this is called a spring. Okay, this is called a spring. What is the nature of a spring? Can you tell the nature of a spring? Suppose this is this. What is the nature of this spring? If you apply at this end, if you are applying load in this direction, then what will be the nature of this spring? It will try to restore the shape and size, or it will try to restore the deformation or deflection or change in length, because this is the spring. You hold at this end and apply the load in this direction. So what will happen? This spring will change the length. Okay, that is called deformation, or it is called elongation. Okay, or simple displacement. So this spring will maybe like this, like this. This spring, once you apply load, so it will be like this. Yes or no? Tell me, dear.
Yes, sir.
So it will try to restoring means resistance force will come, and it will try to contract again, because here it is elongated, that length increased, it is elongated, so it will try to contract again, it will try to get the original shape again. So it will have a restoring tendency. So nature of a spring is always a restoring. So what type of force will be there in case of a spring? If you talk, it is the restoring force, means it will try to regain its size. Hmm? That's the meaning of it. What is the nature of damper? Okay, this is called damper. This is the spring, and this is the damper. Damper, I'll show you the separate diagram. Damper is like piston cylinder arrangement. It is not exactly a piston cylinder, but yes, you can understand in that way. So you just say this is what cylinder, and this is the piston. This is the piston. Okay. Here they may have a very high viscous fluid, a high viscous fluid. Okay. Suppose force is what going in this direction. So this rod will go inside. Yes or no? It will get this shape here. So this fluid will try to oppose it, but it is the smooth. It is the smooth force because hydraulic fluid will be there and hydraulic press will be a very smooth. huh? So once load will be acting in downward direction, so this rod will try to go inside, but that time fluid will try to oppose it smoothly, very smooth. Huh? We just think. So we just think this example. Suppose you applied load here. This is the wheel. So this block will go in this direction. It will go in this direction. But if you leave, suppose this is damper is not there. If you leave it, then this spring will try to restore. Means it will try to go in this direction. But it will go very fast. It will give jerk. It will try to oppose the motion. So smoothly it will go back. Tell me dear, you guys are getting the concept or not? Say yes or no.
Yes, sir.
So the damper will have a resistance of the motion. I mean, see, you just think, suppose we don't have damper. If you, this is the block and wheel we have. Wheel means frictionless, okay? Frictionless. If you apply load in this way, so this trolley will go in forward direction. But if you remove the load, then because of the restoring force uh, uh, stored in spring, this restoring force will try to get back this trolley as soon as possible. So if this trolley will go back very fast, it will give jerk. Yes or no? Shock it will give. So so what will happen? So to eliminate that shock, we will have a damper. What is the concept of damper? I told you. Once this uh, trolley will get back because of the spring, so this you can say this piston or just say rod will go back very fast, but here we have a fluid. I told you this is the diagram I had explained. This is the say piston, and this is the cylinder. Here fluid we have filled. If this piston very fast will go downside, but this fluid will resist it very smoothly. Very smoothly it will resist. So it will go back, it's okay, but very smoothly it will go back. That's the reason we are using damper. You know what is the meaning of damper and what is the use of damper? Say yes or no. Tell me, dear.
Yes,
Tell
sir.
me, dear.
Understood.
Understood, no? Okay. See, in your bike and all, see, you have seen both sides below the seat. You have seen this rod, and over the rod, you may have a spring also, no? Over the rod, you may have a spring also. So basically, spring and damper both. If you check, this is in our like in bike we are saying shocker. Shocker means to absorb the shock. Hmm. So this system. So if you check the shocker, so a part of this spring mechanism will have a like this mechanism also. I mean, if you check that sometimes if you go to bike mechanical mechanics and all, so they may remove this shocker and they may fill the fluid again, so that again damper will work nicely. So that in your bike and all you are getting or you are having a good shock absorber. That shock absorber because of both mechanism, spring and damper both. So that damper I told you, in your bike, this damper will be like this. This will be a small um, kind of the pipe inside that rod and fluid, everything will be there. So that bike mechanic will what they will do, like he will remove the shocker and then he will again fill the fuel, maybe mobile and high viscosity fluid. Yes or no?
Yes, sir.
All right. So it is very clear now. Okay. So so here this is the like K. This K is spring K will give the what is the K? Suppose this is the spring and this is the K. So this K is nothing but spring coefficient. huh? This is called spring coefficient, and we'll have a damper. Okay, this is the damper now. huh? This is the damper. Okay, this is the damper. So this damper called C, which is called damping coefficient. What it is called damping coefficient. Okay, remember. All right, done. Now see. So check this. Here we have a continuous force. So this is the force vibration. hmm, Force vibration. Here we are uh, applying the load, but after the force, there will be motion x, and then you remove the force. So this is the free vibration. Okay, and here because we are having the own mass or own weight, no? Self weight, because of the self weight also, this in this case will have a deflection. So self weight deflection also a kind of the force vibration. All right, and this is the force. So all three we have. Anyway, now check. So a very simple term like time period. This is the 12th standard only. You know time period T is equal to what? It is 2 pi f. No? What is the f frequency? Hmm? And what is T time period? So 2 pi frequency f will be 1 by w angular velocity. No? 2 pi by w. What is the w? W is nothing but it's angular velocity. Hmm? Radian per second. All those formula you see. So Tp is equal to 2 pi by w, or F is equal to W by 2 pi. Take the formula. So these are the basic formula. Time period is equal to T divided by 2 pi by W, and frequency is nothing but F is equal to 1 by time period. So again W by 2 pi, or here you can write W is equal to 2 pi F. Meaning is same, the same meaning. Yes, so this very basic you should know. Now, I just want to tell you this F. Okay, now this I will explain. Suppose this is the spring mechanism. Okay, they have this is the mass M. This is the spring mechanism K. So obviously we'll have a deflection in downward direction. This is also called delta. So now another diagram I will draw. So here we'll get the deflection. This is the deflection. So K. So we'll have a restoring force in upward direction. What will be the restoring force? K into deflection. X. What is the X? X is the deflection. So you remember F is equal to K delta. I told you X is nothing but delta. Deflection, it's your choice. You can show like deflection is delta or X, meaning is same. Similarly, damping coefficient. Okay. Like F is equal to K into delta for the spring. So for the damper, F is equal to C into V. Okay. All right. C is the damping coefficient. Hmm? C is the damping coefficient, and V is the velocity of the fluid. F. What is the F? F is the damping force or force applied on damper. Okay. This formula you remember for the spring, like here. Hmm? For the spring, check deformation is what? X. So for the spring, what is the spring force restoring force? K into X. For the damper, what is the damping force? F is equal to C into V, velocity. Hmm? What is the velocity? It is distance by time. What is the distance? It is x. So we can write x by t. Can I write x by t?
Yes, sir.
Can I write x by t as a velocity? Yes. Distance by time. What is the distance? X. X by t, can I write x dot?
Yes, sir.
Dot means per unit time or divided by time. So that damping force you can write F is equal to C into x dot. What is the F? Kx for the spring, F is equal to Cx dot for the damper. Is that clear?
Yes,
Okay.
sir.
Now next word is resonance. It is very nice word. What is the mean of resonance? You know, in 12th standard physics you had seen. No? Suppose I was just thinking this way. Like anyway. Okay, this is what river. No? This is the river. River. Okay. All right. Now over the river, this is what road. Huh? So obviously this is the river and this is what road. Okay. So what you may have? You may have bridge. Yes or no? Let's say this is what? Bridge. Clear? I'm just giving the example, 12th standard physics example. You might be have seen that example if you recall. What was that? Suppose this is the one army parade. They are marching here, ups, downs. They are doing like march, as usual march. Okay, ups, down, up, down. That leg ups, down, ups, down. That example you have might be seen in 12th standard physics. Here the army parade going on. They are crossing the bridge. They are crossing the river over the bridge. Okay, so march is what they are doing. Legs going up all together and going down, ups, down, ups, down. So they may have a one frequency. Okay, they may have one frequency. Yes or no? They may have one frequency. So here, because every time on same time, all the uh, like a cadet, their legs going up and then going down, ups, downs. So they may have one frequency, right? Repeating things going on. Hence, they have a frequency. And this bridge material will also have a frequency that is called natural frequency. Hmm? So if this frequency and this frequency will match, then the amplitude of this material, okay, because whatever the material it is used to make the bridge, that material I'm telling, because natural frequency is what? Of that material only. If I'm saying natural frequency of the bridge, then what is the mean? Mean is what material we have used in the bridge, that material natural frequency. And the frequency generated due to march of the cadets. So this frequency and this frequency, if it is matched, then it is called a resonance. Hope you understood. Okay, then what will happen in this situation? It's very simple. Because of the resonance, what will happen? It's a thing like whatever the amplitude of the um, material having natural frequency, that material amplitude automatically increases. Now see, what is the mean of it? Suppose this is the bridge material's natural frequency. Okay. Now this is the cadet they have generated due to March, that frequency is this one. And it is matched at the same time it is high, at the same time it is low, means it is matched. But in this case, both frequency, this is F2 and this is what? F1. So the another plot you may draw like this. So this amplitude increases or not? So this amplitude increases. So this amplitude is the combined effect of the both, because frequencies match, so amplitude will be added. So this amplitude added, it means this bridge will start oscillation. It will start oscillation. Okay. And if it will start oscillation, so they may have a chance to break the bridge because of that oscillation. Amplitude increases, hence they may have chance to break the uh, bridge because of this resonance effect. You understood what is the resonance now? This example we had seen in 12th standard physics.
Yes, sir.
All right. So this is resonance. So why we are talking about resonance and all? Why? Because we'll have a vibration, and I told you vibration means oscillation about one point. This or this very example, simple example, pendulum. This is the original position, and this to and fro motion of the pendulum. Yes or no? So obviously frequency will come. So that's the reason we have to talk resonance also. I think it is clear now. Done?
Yes, sir.
Anyway, okay. So longitudinal vibration. Okay. So this longitudinal is very simple. This is the very simple term. You just suppose this is the spring system. If you apply load in this direction, okay, and if you remove the load, then spring may vibrate in this way. You will apply load, so it will go in forward direction. If you remove the load, it will go back. Huh? But if you remove the load permanently, then automatically it will oscillate in this way to forward and backward, and ultimately it will get stationary condition. This forward and backward, it is very fast, so your naked eyes cannot identify that. But yes, there will be forward backward motion, and then it will come to stationary position. This forward and backward motion called as a longitudinal vibration. Done. Transverse vibration, basically it is because of the bending, like this is the cantilever, and here you are applying the bending load or this force. Once you remove this, then cantilever is what in this way, but your vibration or motion will be in upward direction, upward downward, upward downward. So this is the one axis, but motion is what like this, hence it is called transverse. You understood what is the transverse vibration? Perpendicular vibration. Perpendicular to the acting axis or reference axis. You can consider this is the cantilever. So this is your axis now, but vibration is what in this way. No, in this way. Okay? Yes or no? This is called transverse. What is the torsional? Torsional is always because of the twisting. I mean, this is the case. We have a disc like this. Okay. You apply the, that kids, or we in our childhood we had like small toys. So that key toys, if you rotate that key, and then if you leave that toys, then that toys automatically it will go in forward direction. Yes or no? We'll have a keys here.
Yes, sir.
If you rotate this key and leave it, then this toys will move in forward direction. So that twisting, whatever you are giving, in that, because of the twisting condition, twisted and untwisted, see, it is given automatically. It will give the torsional vibration. I hope you understood all three types. Tell me, dear.
Yes, sir.
Yes, sir.
Right. So why I'm telling this, because it is very basic. I know you guys have seen
Sir, your voice is breaking.
Okay. So now it is fine. Now it's fine.
Yes, sir.
Yes, sir.
Yeah. So I told you that weightage of this vibration is 2 marks or 4 marks. Okay. This is max and this is min. So for the 2 marks, you don't go for the one subject. It's long, it's a mechanical vibration, it's a complete one subject in your might be semester or in mechanical engineering. So I will suggest don't go for thoroughly. Whatever important I'm telling you, you go through that only. That is more than enough. And with the help of that, all question you can solve. No issue. And very basic question they are asking. All right. Now we'll write the equation. As I told you, to and fro motion. No? To and fro. This to and fro motion you might be heard in your 12th standard physics. That is called as a SHM, simple harmonic motion. That pendulum and all. Do you remember? That to and fro means one, uh, the center point, or you can say it is origin. You can say, okay, and we'll have a pendulum motion to and fro like this. Yes or no? So for that,
Yes,
we
sir.
will have we will write the equation. Okay, that SHM equation means simple harmonic equation. So if you write that, then you may get this one. You can write directly. You write SHM simple harm. No need to do it derivation and all, because already you have done in your 12th standard. But still, if you want, then this is what this sinusoidal. What is this? This is the to and fro plus minus hmm, to and fro motion. No, first positive negative positive negative positive negative means it is what to and fro motion. So this is the SHM. So this you can write a equation is equal to x sine theta, or sine theta is omega t also you can write. Simple. Theta is the angular displacement. It is angular velocity in time. So x is equal to x sine omega t. You can write. This is the equation of the this sinusoidal wave. No? And then you can write x dot. You may get this omega cos omega t, na? Sin omega t, cos omega t, and omega again you may get. Again x dot, then you may get this. If you take this side, then it will be x double dot uh, plus w square sin omega t is equal to 0. X double dot plus omega square, okay, into that equation x. check this value. This is nothing but x is equal to 0. What is the mean of it? Meaning is this x double dot. Okay, x is the displacement, or you can say displacement or distance. Okay, or distance, depends, scalar vector. X dot is x by t, means it is velocity. X double dot, if I am saying, then it is velocity by time. What is the velocity by time? It is acceleration. Yes or no? Say yes or no. So if I say x
Yes,
double
sir.
dot, x double dot means acceleration, and x means it is displacement or distance. Okay. So now,
So dot is nothing but differentiation with respect to time.
yes, dot means differentiation with respect to time. That's the meaning of dot. No? So now this is the standard format to write any SHM for any object. Any object which is performing SHM, simple harmonic motion, then this is the standard format. Okay. This is the standard format equation of SHM. What is the standard format? X double dot, sorry, x double dot plus w square x. Always remember w is the angular velocity. Okay, angular velocity, radian per second. This can also be written as in terms of hertz. If the frequency is what hertz, then what you will say? This is the frequency also. Why I am saying frequency? Because I told you w is equal to 2 pi f. So angular velocity is directly proportional to frequency, with only constant will come, right? So you can say w is directly proportional to frequency. So it depends. You have to check the frequency. If this w frequency is given radian per second, then you say it is angular velocity. If that value unit is given hertz, hz, na hertz, then you say it is frequency. No need to get any kind of confusion. That frequency only will tell you. Now you understood that is standard format of the SHM, simple harmonic motion. What is the standard format? That x double dot plus w square x is equal to 0. That's all. Done. If it is free vibration, it will be 0. If it is forced vibration, so something you may get right side. But for free vibration, this is the standard equation. Should I go for next?
Yes, sir.
Okay. Now see, the spring, you can check this spring with two types of connection we have. Three types basically, ladder connection also. One is series, one is parallel, another is series and parallel both. Just like resistance or capacitor you have seen your 12th standard physics. So same thing here we have. So spring is what in series. So series in the sense, see, this is the fixed point. So this spring will be considered as a series because one end is what finished, another end of the spring is what is started. One end is what finished here. See, this is the point. You just say this is 1 and this is 2. And this is 2 and this is what? 3. So for spring 2, initial point is what? 2. For spring 1, ending point is 2. So ending point and initial point will be same. If it is same, then it is called a series spring. Okay. So now this spring, now both spring are in series. Now I want to write equivalent. This is the equivalent. Okay. So I just want to write equivalent, so that equivalent will be KE. Just I want to check if equivalent spring is what? KE for K1 and for K2. Then what will be the result for that? I mean, some relation we should get na, between K1 and K2. If I want to write equivalent, then I want to write that result. Okay, we'll see. Now for this spring, obviously, if you apply load in downward direction, F force you applied, so deformation in this spring will be delta 1 and deformation in this spring will have a delta 2. What is the total deformation? It is delta. So delta 1 plus delta 2. I told you, if suppose this is the one spring, okay, and this spring is what K, and here deformation is what X. So what is the restoring force? It will be F is equal to K into X. I mean spring stiffness into deformation. So for this is spring stiffness K1 and delta 1 is the deformation. So you can write that value, and obviously one thing is very common. What is the common thing? That load for the both springs it is same. I mean mass M is the mass, but if you write weight, then it must be same. Hmm? It must be same for the both. Okay, yes or no? Like for both
Yes,
spring,
sir.
that weight or mass will be same. Now, so I will write the deformation, total deformation. So I can say now this delta is the total deformation for this system. Okay, uh, for this system. So what is the F? F will be Ke into delta. Yes or no? Ke into delta.
Yes, sir.
So what will be the delta? It will be F upon Ke
K.
for this one. So similarly for delta 1, what is the delta 1? It will be F. Instead of F, it is the mass. Mass in the sense weight. If I write what is the weight, force, so you can say M into G. So I'm not writing M and G, simply I'm saying uh, force, downward force. So delta 1 will be F1 divided by K1, because force or mass will be same, so I'm not writing F1, F2. Similarly, delta 2, it will be F upon K2. Agree with me?
Yes, sir.
You write all the value. Delta is equal to F by K. So this is F by K. Delta 1 F by K1, F by K1. Delta 2 F by K2, F by K2. F you can remove. So automatically Ke you may get. What is the Ke? It is K1, K2 divided by K1 plus K2. This is the equivalent spring of the series connection. Hope you understood this. You understood or not, dear?
Yes, sir.
Okay, in terms of resistance, do you remember it was series resistance or parallel resistance?
Exact opposite of this, sir. In
Huh.
series, it will be summation.
So
In parallel, it will
for
be
yeah,
product.
so yes, it is opposite. So spring connection and resistance connection, it will be opposite, but capacitor and spring connection must be same. Hope you understood, because resistance in parallel, if you calculate, suppose this is the resistance, no? This is the ending point, initial point, point 1 and 2. Here resistance is what? R1, here it was R2. Both connection are parallel. If I said what is the R equivalent, then you had calculated R1, R2 divided by R1 plus R2, parallel. So resistance parallel and spring series, both are same. Means connection is what? Just opposite to each other. Anything you can remember, it's your choice. You might be remember the derivation. I will suggest don't go for derivation. You just simply remember the one thing, like okay, connection of the springs are just opposite to the resistance connection. Whatever result was in series resistance connection, the same result you may get parallel spring connection, and what was the result of parallel resistance connection, you may get the same result in case of series springs. That's all done. Yes.
Yes, sir.
All right. Most of student, I think they are watching recorded videos also. I'm right, Brini?
Yes, sir.
Okay. So for them also, I'm saying any kind of problem you may get in vibration. So any question, if you have, then you can share that question after the, like once I finish the vibration. Because I told you main vibration is one subject. So many numerical are available. for many kind of different types of the question, like for series springs, parallel springs, and free vibration, force vibration, damper, without damper. So many questions are available. So I will suggest, like what I'm teaching you, focused on that part only, because it is one book. If you check vibration in library, so you may get one complete book, mechanical vibration, and it is like more than 200 pages. So that full book you don't have to go through it. Selected topics you have to go, and you practice the numerical from that selected topic only. For your choice, for your interest, if you want to practice another or different numerical also, if you are facing problem, you send me, I will give the solution also, no problem. But I will suggest, like whatever topic I'm touching, the same topics numerical you have to touch. Okay, so in that way, within 10 hours you can finish your vibration. Otherwise it will take more time. Okay, anyway, this is the parallel connection. Check parallel connection. Here this is the uh, one end. Okay, and this is the another end. This is the mass, suppose. Okay, so for mass, same spring, one spring here K1 and another spring K2. So here also and here also it is common. I mean, if you check, this connection is like this, because here connection must be same. So this is same. Here both connected for the same body, so it is same. So at the same end, two connection, two different spring connection you are getting at the same point, it is called parallel. This is what parallel. I told you here, parallel resistance. Check. See, same point will have a two connections, so it is called parallel connection. All right. So this is the parallel. Now, how do you solve parallel? It's very common. Like very simple also. Whatever the deflection you may get here, the same deflection you may get here also, if it is balanced. This mass is what balanced. So whatever the deformation or deflection you may get here, you may get here also. Same. So now how to derive this? So like previous one, if you go for the previous, check total mass. If you write F is equal to, it will be, I mean, F is the restoring force. You can write. So like, I mean, equivalent, total force equivalent. So this two spring you have converted into single, and it is like this one. So here, what is the force? F. F is equal to Ke into total deflection. And what is the F1? You may get, it is K1 into delta 1. What is F2? K2 into delta 2. But F1, F2, F, all three are same. So you can write F is equal to K1 delta 1 plus K2 delta 2. Okay. Now, if you do that, and this is the Ke delta. So delta, delta, delta everywhere same. So what you may get? K is equal to K1 plus K2. It's your common analysis only. This is the result. Now, what is the important? This derivation is important. What is the important? The final value you have to remember. Another thing, can we, the same connection, can we write in this way? That is the one question arising here. Okay, the same connection, parallel connection of the spring, can we uh, like uh, give this connection? Can we give connection like this? Is it possible?
Sir, in one, the first condition where both springs are on the same side, the deformation will be same, sir.
Okay.
But in the other one, it will be exact opposite. So, like if one deflects x, the other one will deflect by minus x.
Huh. Okay, magnitude wise must be same.
Magnitude will be same.
Yes, correct. Magnitude will be same. Now the thing is, in another way also you can understand, like the same mass. Okay, as you said, one side, if it will go this side, so what is the deflection you may get? It will be positive, or it will be, suppose, negative compression, but at the same time we will have a tensile here, plus it will elongate and it will compress, but that amount must be same. And here also deformation you are getting same. Check. So it means this and this, the overall will be same. So the same parallel connection, okay, sometimes you may get uh, this connection like this, or directly you may get this. Don't think this is what series, because this diagram and this diagram is, it seems a very common diagram. It seems this diagram and this diagram, it seems very common. So don't get confused there. Or else I will tell you another example to understand this. Simple, you just this is the mass. You hold this mass and stretch this mass. If you hold this mass and stretch, then how it will looks like? It will looks like this. Check. Oh, sorry. It will looks like this. Yes or no? If you hold this mass and stretch in this direction, then this mass will looks like this or not? Tell me.
Yes, sir.
So this diagram is nothing
Yes.
but this.
Yes, sir.
Ah, then this way also you can understand. There should not be any confusion. Yes or no?
Yes, sir.
Ah. So if it is parallel, then it will be added. It's just like a series resistance. You might be have remember 12th standard physics. So this is the series resistance, no? R1, R2. So if you
Yes,
say
sir.
what, if I say what is the equivalent of this, then you may say R equivalent is equal to R1 plus R2, because current will be same, hence it will be added. So series resistance result will be equal to parallel springs connection. Done?
Yes, sir.
Done, sir.
All right. So now this we have the spring mass spring mechanics mechanism. So you just draw this diagram. For this diagram, I don't know where it is removed, or one page is what removed. Actually, this derivation is for this system. This is the one complete system. This is the spring and this is the mass. Okay. So for this diagram, for this derivation, you please draw the diagram separately. It was there. I don't know where, how it is removed. So this is what is spring. This is the mass. And if you apply load downwards, it will have a deformation X in downward. Done? This is the diagram. Okay. So if I say what is the restoring force of the spring, so you have to say F is equal to Kx. Okay. What is the F? F is nothing but mass. It is the force and unit is Newton. So Newton is nothing but mg. Mg is equal to Kx. Huh? So K divided by M is equal to G divided by X. Understand? Tell me, dear.
Yes, sir.
All
Yes,
right.
sir.
Okay. I will write kinetic energy for the mass system. Tell me any kinetic energy for the spring? Any kinetic energy for the spring?
No, sir.
No. What is the kinetic energy? Kinetic energy means a body will move from one place to another place. So that spring is not going to move from one place to another place. What part is what going to move from one place to another place? This
Mass.
mass system. Maybe elongation will come, then mass will get this position. Maybe. No? Maybe get this position mass. So mass is what going to move from here to here. So always remember, okay, this mass and spring mechanism, you always remember mass will have a kinetic energy. So you can write kinetic energy of mass. How to write kinetic energy of mass? What is the for any mass system? What is the kinetic energy?
Half mv square.
It is half mv square. Very good. 1 by 2 mass into v. What is the v? If distance or displacement is what x, then x dot
X
will
dot.
be x dot will be velocity and half mx square. All right. Yes
Yes,
or
sir.
no? Okay. Why it is going to be a negative value? Because uh, there is a loss in the kinetic energy of the mass. Okay. Why it is lost? It's very simple. Because whenever you will apply the load, okay, so it will go down when you apply the load, but again it will be restored by the spring. It will be restored by the spring. So for spring, it will have a positive energy, that is restoring energy. Okay. But at the same time, that mass will lose the kinetic energy, because it will get kinetic energy because of the applied force. But once you remove the force, then automatically it will regain its position. Hence, it is losing kinetic energy. That mass I'm saying. So that it will have a negative sign here. You understood or not there?
Yes, sir.
Because once you apply the load, see, simple thing, suppose one block you have in your hand and you are going to throw that block, but somebody is there and behind you, and he or she is going to hold your hand. So what kinetic energy should get that block by your hand, that same kinetic energy it will not get. Why? Because someone is what going to hold your hand from backside. You understood?
Yes,
So
sir.
spring is like that only, because spring will try to hold, and it will try to get back that mass system in upward direction. So finally, mass system will lose the kinetic energy. I hope you understood. It is like, okay, you are freely you are suppose you are preparing gate, and last month you are having so much headache and all because you have not revised properly. So you are freely you are don't try it, but I'm saying you freely you are going to hit your head on the wall. Okay. And you are running from one side to another side, and you are going to freely hit on head on the wall, and someone is your there behind you, like your brothers, your sister, or your parents. Someone is what going to hold from backside. So whatever the like stroke you should get on your head, that you may not get. Why? Because someone is what going to hold from backside. You got my point now?
Yes, sir.
All right.
Yes, sir.
Yeah, don't try. Now, so obviously you may have that less kinetic energy comparatively. So that's the reason we are getting minus sign. But now what about the energy in case of the spring? So this spring will have a potential energy because it is a static condition, but it whatever the kinetic energy it is going to increase or decrease in mass system, so the same energy will be, because energy cannot generate or cannot end, you know that. Okay. It can transfer from one part to another part, like whatever the kinetic energy you are getting in the mass system, it is because of the same energy will be stored in spring also. But that because spring is a stationary condition, hence that energy will be in form of potential energy. That's the mean of it. So that if you for the total system, if you write the energy, then it will be total energy, which is called kinetic energy plus potential energy for the system. I'm saying for the system. If I say system means spring and mass both. So in spring you may have a kinetic energy, and in mass you will have a kinetic energy, and in spring you may have a potential energy. Okay. And potential energy of the spring, it is half kx square. This is the one derivation. With the derivation you may get this. Okay, half kx square. But I will suggest you remember, like for the spring, potential energy will be half kx square. And don't confuse, this is kinetic, like you may relate to half mv square here, half kx square. Kinetic, no, this is the potential energy of the spring. For the spring we don't have any kinetic energy, always only potential energy. So I will suggest potential energy for the spring you remember. Actually, half kx square is the one derivation, but I'm not going to derive because it is the waste of time. Okay, you just remember it is half kx square, potential energy of the spring. It is the derivation, but no need to derive. You just remember half kx square. What is k? It is spring stiffness What is x? It is the deformation or deflection or displacement. All right. Now, so this is the potential energy. This is kinetic. What is the total energy? Obviously, it must be constant. This total energy also called as a mechanical energy. Okay, mechanical energy must be constant. So total energy will be sum of both, and this total energy for the system. System means mass and spring. So for mass, it is kinetic energy. For spring, it is potential energy. Sum is equal to constant. Any constant, differentiation will be zero. You know that, no? 12th standard mathematics. Any constant differentiation will be zero. You differentiate that energy and make it equal to zero. So you differentiate. So kinetic energy, if you differentiate 1 by 2, mass is constant. It is the x dot. If you differentiate, then what you may get? I will write here 1 by 2 m. If you differentiate with respect to time, then you may have x double dot square. Agree?
Yes, sir.
Yes, sir.
Okay. Plus 1 by 2 k into x square. If you differentiate with respect to time, can you differentiate with respect to time? I think you just correct this. This derivation. I was in very hurry, has made mistake. You can write in this way, check. So it will be very clear. It will be 1 by 2 m. Okay. This is the x dot square. Okay. Already square is there. Now, if you want to differentiate, then what you may get? 2 times x dot into x double dot. Agree with me?
Yes, sir.
And now it is correct. Check. Because it is the x
And for
dot
the
square. Yes, yes, x dot square. Hence, you will write 2x dot and x dot again differentiation you have to do. Then it is x double dot. Actually, I was hurry, so I made mistake, but now it is corrected only. Check it is correct or not.
yes, sir, it is
Yes,
correct.
sir.
And sir, for the second term, it will be
Huh,
1 by 2 k
huh,
into 2 into x dot into
uh,
x.
yes, 2x into x dot. Yes or
Yeah.
no? Agree? Is
Yes,
equal to
sir.
equal to 0. Now you may check x dot we have here, x dot we have here. You remove it. 1 by 2 m, 1 by 2, not m, 1 by 2, 1 by 2. So you may have mx double dot plus kx is equal to 0. Check. Agree?
Yes, sir.
Okay. Now, again, this is okay. I mean, for this spring system, you got the SHM equation, and this is the SHM equation for that. But we had already original equation. What was the original equation? If you remember, it was x double dot plus w square x is equal to 0. Yes or no? Standard SHM equation, check this one. X double dot plus w square x double dot plus w square x. Yes or no? Standard equation. Can you compare
Yes,
from the
sir.
standard equation? Ah, if you want to compare this standard equation, then you have to write this in this format. So I will write this. It is x double dot plus it is k by m into x is equal to 0. Now it is same one. Now you
Omega
can
square is equal to k by m.
right. So you can compare this. So all right. You can write this. So it is w square is equal to k by m, or w is equal to k by m. This is the natural frequency of the spring mass system. You have seen might be w is equal to root k by n. So this is the frequency. Actually, this is the angular velocity. It's depend. I told you it depends. If it is given radian per second, then it will be uh, angular velocity. Or if you write frequency, then f is equal to w by 2 pi. No? So it will be 1 upon 2 pi root of k by m. So this will be in hertz. This will be in radian per second. You understood? So for the spring mass system, this is the frequency in hertz 1 by 2 pi root of k by m, and angular velocity in radian per second, it is root k by m. Up to here today. Up to here it is clear?
Yes, sir.
Okay. So we'll continue this. I think 2-3 lectures required for the vibration in short. No? 3 lectures I need. So I'm sure once I will finish 3 lectures, so all questions you may crack. All right. And you guys keep revising. I'm trying to take alternate class, sometimes regular, sometimes alternate. If I'm saying alternate, it means I'm giving time to you guys to revise the previous topics. That is important because I told you that time, like if continuously going to cover the topics, new chapters, but we are not revising previous chapters, then it is completely useless. I suggested already, like don't, if it is not necessary. If toppers view also, if you go, then it is not like 100% completion of the subjects. 100% syllabus completion is required. No, it is not at all. From our side, we'll give 100%, but for it's your choice. You are concentrating 80%, 75%, or 90% syllabus. It's your choice. So according to your energy, according to your endeavors, you choose that. Like okay, 80% I will prepare. I will skip this subject. I will skip this chapter. It's your choice. So for that reason, I'm saying don't go for the all topics, like whatever the topics you are thinking, okay, it is complicated or it is going above my head. So don't touch that topic. It's okay because you have 65 question. Calculation I had given many times, and those who are watching recorded video also, for them also I'm saying again, total we have a 65 question. Okay, for 100 marks, and in 180 minutes, no, 180 minutes. Okay, I will suggest you, if you go on correctly only 40 question also, if you are going, then still you may have more than 60 marks. And more than 60 marks means you are below 50 rank. Below 50 or under 50 rank. Very simple. So selection is done only 40 question correctly. If you are doing that, is your selection is already done. No doubt about it. Okay, it is very clear things I'm telling you. If 25 question 2 marks you have done, and rest 1 marks also if you do, then more than enough. So 40 to 45 question must be your minimum target. 40 to 45 question out of 65. So just think, out of 65 you are going to hit 40 questions, so 25 question you have option to skip that. If you are planning 40 to 45 question, so time margin also you may get more, because for 65 question, if you go for 180 minutes, you may get might be 3 minutes for one question, or less than 3 minutes, 2.71 something. But if you go for 40 question only, so you may get more than 4 minutes, 4.5 something. So that time margin also you may get. So very good planning is required for the competitive exam. I always tell like this, okay, like preparation is one side and your good planning is what another side. Okay, so preparation with good planning is better side actually. Some people, they are having a good preparation, they have revised well, but they are not planning well. So in that time also, in 3 hours you might be made some mistakes. So automatically you may lose the marks, your rank will go down. Hmm? So planning is very important for the competition. And now this is the correct time to plan everything, because you have 1.5 month, right? So need to plan, like okay, what chapter I want to revise 4 times, 5 times, what chapter I want to revise only one time. If question, simple question I will get, then I will solve, otherwise I will skip that. With that mindset you have to go. Don't go for like okay, 165 question I have to do, 100 marks I want to hit. No, always toppers marks, 65, 70, 75, that is. If toppers is what getting 75, It means he is not going to try for 100 marks. He is not going to correct 65 marks, 65 question. It's a very simple calculation here. You are getting my point or not?
Yes, sir.
Yeah, so make a good plan in your in your mind. Don't be panic like, okay, time is very less, I have not revised anything, nothing like that. I will suggest you only three subjects you are preparing well, you can get good score in your gate. It's very simple. Out of five subjects are major subjects, right? Out of five subjects are like, okay, I will write here aerodynamics, aero, structure, okay, propulsion. If I say propulsion means jet and rocket both, and performance. Yes or no? And what is the another? Aero, structure, propulsion, and performance. You can say, and then next is what you can say, that subject is math also is
Sp-
included.
Space dynamics, sir.
No, space dynamics is only 2 marks. Major subject I am saying, major subject. Okay. So any three subjects only if you choose, you can take stability. Okay. Stability also. Performance and stability is what combined actually. So any like three subjects if you go, you can get good question collection. No doubt about it. Because many times it happens like aero getting uh, 12 marks, structure getting maybe 15 marks or 12 to 15, propulsion is what like 12 to 15. So if you add all three, then automatically your marks will be more than 40 or 45 something. And then if you out of 25 marks aptitude and math, 20 marks you are getting, then automatically 60 marks you reached. Only three subjects, core three subjects and math and FT, if you do properly, you can get nearby 50, 60 marks very easily. Okay, I will say like you are getting, suppose just for example, aero 10 marks, structure 10 marks, propulsion means jet propulsion and rocket propulsion 10. I will sure like propulsion is more than 10. I'm sure structure is more than 10. I'm sure aero also more than 10. But I'm considering list 10, 10, 10. It is 10, 10, 10, 30 marks. Okay. Math and FT, you are getting suppose 20 marks correctly. Total 50. 100% selection. 100% selection. You may get 50 marks more than enough. So I'm not saying go and skip the performance. Maybe someone have a choice to practice performance. So they are taking performance, propulsion and aero. They are going to skip a structure. I'm not saying like you skip it. It's your choice. I'm just saying like, okay, the plan, how to set up everything in your mind. I'm telling you how it is very simple to get 50 marks. That is my intention to tell. I'm not saying like you skip any subject or don't prepare. No, whatever you can prepare, you please prepare. Give your 100%. But I'm saying like I'm going to dilute your mind. Like I'm not going to pressurize you, or I'm not going to panicking you. I'm just dilute your mind. Like I just want to tell you it is very simple only. Don't get panic. Don't take overburden on your head. That's my intention. I'm just saying you like how simply you can get 50 marks, and 50 marks means 100% selection. That is true. Any IIT you may get. You plan there. Okay. Should I stop now?
Yes, sir.
All right. Okay. Thank you.
Thank you, sir.
Thank you.